everyone, it's Justin again, and this is Sir Wigglesworth. Yes, he's a sock puppet. My cousin and I made him years ago as a joke, and I just found him while cleaning out some old things. Now, I'm mailing him back to my cousin to give him a good home. I found 3 different box options that I can ship him in. He fits in any of them, but how should I decide which one to use? Maybe I could choose the one that uses less material and creates less waste. But how can we calculate which box uses less material? Big companies ship thousands of boxes every day, and choosing packaging that uses less material can help to cut down on a lot of waste. I want to do the same thing here with my sock puppet. Pick the box that uses the least material. But how can I figure out which box is the best choice? We can calculate something called surface area. What do you think surface area means? Well, we know the area of a 2-dimensional shape is the amount of space inside it. So the surface area of a 3-dimensional figure is the area of all of the surfaces, or faces, that combine to make it. It's like taking all of the areas and adding them together to cover the entire surface of the prism. With this being one of my box options, how many faces would we need to calculate the areas of to get the entire surface area? We need to calculate the areas of 3 rectangular faces and 2 triangular bases, which is 5 faces in total, and then add them together to get the area of its entire surface. What do we need to know about a rectangle or triangle to calculate its area? We need the dimensions of its base and height. So to calculate this box's surface area, we need to know the base and height of each rectangular and triangular face. Let's go ahead and work with this 3D view that we can see through so we can visualize each face. And here are its dimensions. First, we need to make sense of these dimensions and which edges they apply to. If this distance between the bases is 9 inches, what other edges have the same distance? Yeah, these 2. And since these are 3 inches and 4 inches, where else can we find those same measurements? Up here on the other base. What about this 5 inches? That's also the dimension of this edge right here at the bottom. Okay, I think we're ready to calculate the area of each face. It doesn't matter where you start as long as you can keep track of which faces you've already calculated. But go ahead and start with one of the bases. Can you calculate the area of this base? Pause the video now and give it a try. Since 3 and 4 meet at a right angle, those are the base and height of the triangle. 1/2 times 3 inches times 4 inches gives us 6 square inches. I'm going to keep track of the areas of all the faces over here along the side. You can decide how you'd like to keep track of all the areas on your paper. Maybe you do something similar to me and sketch or jot down a description of each face along with its area. Next, let's calculate the area of the other base. What is this base's area? Yeah, since the bases in a prism are the same, they'll always have the same area as each other. So let me jot that down along the side. Okay, now what do we need to calculate? We still need to calculate the areas of the 3 rectangular faces. I think you're ready to take it from here, though. Find the areas of the rectangular faces on your own. Since this length will also be 9, this rectangle has the dimensions 3 by 9, which multiply to give it an area of 27 square inches. This rectangle at the back is a 5 by 9 rectangle, which gives us an area of 45 square inches. And for this final rectangle, we can multiply 4 by 9 to get 36 square inches. Now that we've calculated the area of each face, we can calculate the surface area of the prism. What can we do with all these calculations we just worked through to get the total surface area of this prism? Yeah, let's add these areas together. 6 plus 6 plus 27 plus 45 plus 36 gives us 120 square inches. Now we know that this triangular prism box has a surface area of 120 square inches. So let's calculate the surface area of this box next. Here's a view of this box that we can see through so it's easier to visualize all the faces, and here are its dimensions. Since this box is a rectangular prism, what shape are all of its faces? These two faces are rectangles, and so are these two, and these two. So that's 6 rectangular faces to calculate the areas of in order to find the total surface area of the prism. Okay, that's not so bad. We can definitely add the areas of 6 faces together to get this prism's surface area. But wait, maybe there's an easier way. What did you notice about the pairs of rectangles I just highlighted? In other words, what's true about each pair of parallel faces that can help us calculate the surface area? Yeah, those opposite or parallel faces have the same areas as each other. How can that make it easier for us to calculate the surface area? Rather than calculating all 6 of these areas separately, we could just calculate one from each pair and then double it to account for the others. It doesn't matter which faces we calculate the area of first, so I'll just start with this pair. Both of these rectangular faces have dimensions of 3 by 8, which gives us 24. I'll jot down that we have 2 faces that are 24 square inches, and we may as well multiply that by 2 now, giving us 48 square inches as the surface area of these 2 faces. There are 2 more pairs of faces to calculate, these 2 along the sides, and these 2 at the bottom and top. Go ahead and finish this problem on your own. You can calculate the areas of the remaining faces, then be sure to include all 6 faces to get the total surface area. Pause the video now. These 2 faces have dimensions of 3 by 4, giving us 12 square inches as each of their areas. For this pair of faces, that's an area of 24 square inches. And for the final pair of faces, we have dimensions of 4 by 8, giving us 32 square inches for each of them. 2 faces with areas of 32 square inches is 64 square inches total. Adding 48 plus 24 plus 64 gives us the total surface area of 136 square inches. Now remember, although we were able to work with 2 faces at a time here, if you prefer to calculate each one separately, just like we did with the triangular prism earlier, that's totally fine too. Great, we know the surface area of this rectangular prism. We've only got one more option to calculate. Every face on this box is the same, and they're all squares. Hey, if all 6 faces are the same, that might make the surface area even easier to calculate. We can calculate the area of each face and add them all together, or just calculate the area of one of them and multiply it by 6, since they're all the same. I think you could take this from here. Pause the video and calculate the surface area now. One 5 by 5 square has an area of 25 square inches. And 6 of those same faces, or 6 times 25, gives us 150 square inches for this surface area. All right, now that we know the surface area of each box, which one do you think I should ship Sir Wigglesworth in? Yep, this triangular prism box has a smaller surface area, so it uses less material. Thanks Thanks for learning how to calculate the surface area of prisms with me. And we even explored how to make the process more efficient by reusing calculations when there are faces that are the same. I can already imagine the look on my cousin's face when he opens the box and finds Sir Wigglesworth staring back at him. This is going to be great. I'll see you next time.